This video is covering the acceleration quiz we took on Tuesday, October 2nd. And this is in preparation for the test that we're going to be taking on Thursday. The test is on Thursday. So the first thing, how do you know when an object is accelerating? I accepted any of the following. Velocity is increasing, velocity is decreasing, or in general, velocity is changing. So the triangle right here means change. What does it mean if an object has an acceleration of 3 meters per second squared? That means that the object has increasing velocity 3 meters per second each second. Or each second it is going 3 meters per second faster. This question right here will be on your test. It might not be 3 meters per second, it might be -3, it might be +5, but you need to be able to understand that. Last one is an Olympic sprinter starts from rest. It's a max velocity, so it starts from rest. That means, let's do this in green. That means velocity initial equals 0. It's a max velocity of 10 meters per second in just 3 seconds. What is the average acceleration? So we need to solve for acceleration. So we have velocity final equals velocity initial plus acceleration times time. Plug in our stuff and solve for acceleration. So we have 10 equals 0 plus acceleration times 3. 10 equals acceleration times 3. Divide by 3. Divide by 3. Acceleration equals that, which is the same as 3.3 meters per second squared. The units must be correct or it won't count. Next part. Okay, number 11. Assuming no air resistance, 250 kilograms, that's mass. 25 kilograms, which we don't really use. This is kind of fake info, you don't need it. It's dropped from rest. So that tells me two things. It tells me velocity initial equals 0, and that tells me acceleration equals 9.8 meters per second squared. This is called small g. I will tell you this on a test. The acceleration of a falling object is 9.8. This is acceleration, think of it like this, acceleration due to gravity. And we know it's 16 meters tall, so the distance final is 16. Or you could say the change in distance. We also always know in this class that distance initial equals 0. These two we can treat as the same. So the formula in order to solve for how fast will it be going right before it hits the ground, velocity final is what we want. Velocity final squared equals velocity initial squared plus 2 times acceleration times change in distance. That gives us velocity final squared equals 0 plus 2 times 9.8 times 16. Velocity initial squared equals, we'll say 2 times 16, 32 times 9.8. This equals, let me get the calculator out. (32) times 9.8 equals 313, and the last step is to square it because it's all of this squared. I'll do that in a different color. This is a common mistake, just leaving it as velocity squared equals square root your answer. So let's back to the calculator. 313 square root, where is it? I don't see it. There it is. 17.7. Okay, moving right along, 12a. Now there's 12a and there's 12b. You can pick one. If you do them both, you get extra credit, but you must do at least one. We watched a video of a crazy Euro guy. Recorded his velocity from, his velocity initial equals 16.6, to velocity final equals 66.6, in time equals 10 seconds. How much distance is covered? What's our change in distance? So we've got a couple distance formulas. We have distance final works. We also have both of them have one problem. We don't know acceleration. So in order to use either one of these, we need to find this first. So we have V final equals V initial plus AT. 66.6 equals 16.6 plus A times 10. Before I can move the 10, I have to subtract this because it's plus minus 16.6. 50 equals A times 10. Now divide by 10. 5 equals A. So, which one looks easier? I'm liking this one. I don't like dealing with all these time squared stuff. So I'm going to go 66.6 squared equals 16.6 squared plus 2 times 5 times our change in distance. This becomes 4435.56 equals 275.56 plus 10 times distance. Combine those two. Minus this stuff, minus stuff over here, and now we have how does it work out to? Pause. So this works out to 4160 equals 10. Divide by 10 equals 416 meters. Don't forget your units. Last one. Okay, I like jogging except for the running part. And I imagine that someone is jogging 2 meters per second at a nice consistent rate of 2 meters per second. If the runner decides to sprint for a bit, what total displacement will the runner cover if the sprint contains acceleration of 3 meters per second for 4 seconds? So let's change that color right here. This is two parts. In brown, we have a constant rate. We have a constant velocity. So we have a v constant, and we have a v changing. So this is two parts. This should be blue. For the velocity constant, I can use this formula. And you can only use that formula if velocity is constant. So that means we have distance equals velocity is 2 times 2 minutes needs to be in seconds because this is in meters per second. So that's 120 seconds. Minutes times 60 equals 240 meters. That's part 1. Nice. Now part 2. Well, I need to find distance. We'll call distance initial 0 for the sake of this class. Velocity initial times time plus 1/2 AT squared. Now this is 0 plus velocity initial. Well, how much was he running at before he started speeding up? He was going 2 meters per second times 4 seconds plus 1/2. Acceleration is 3 times 4 squared. So we've got 8 plus 1/2 3 times 16. 8 plus, combine these two because it's a nice whole number, 3 times 8. 8 plus 24 equals 36. Wait, 32. So we've got distance covered when he was accelerating, distance covered at constant speed, and so we get a add these two together for the total. 272 meters. All right, that's your quiz. Good luck on the test.